then 19. 19 looks scarier than it is, I promise. So we have the fourth root. So we have the fourth root of 486 x to the 12 y to the 27 over the fourth root of 6x fourth x y. So here, because it's the fourth root, we're going to have to multiply by the fourth root of 6x fourth y cubed. And the reason we do that is so technically we have 6x to the fourth y, we have one of those. And then we're multiplying it by 3 of those, so then we would have a total of 4. So then with the 4, it would cancel out with the fourth root. So then when we multiply them, we just end up with 6x to the fourth y in our denominator. So that's like the trickiest part of the problem, is just remembering why, like how we actually rationalize the denominator, since we're so used to just working with square roots. So since we did that to the denominator, we have to multiply by the same thing to the numerator. So we're multiplying by the fourth root 6x to the fourth y, and that's to the third. So then for this one, I would recommend choosing the 6x to the fourth y first, and then multiplying, So here, so we have effectively to the first. So then when we have one of them, and then times the cube root of them, not cube root, cubed, we end up with the fourth root of 6x to the fourth y to the fourth. And since it's the fourth, we can cancel them. So then we just end up with our 6x to the fourth times y, and that gets rid of our radical in our denominator. So like if it was cubed, we would have 1, and then we would square it. And then when it's just a square root, we just do 1 times, just 1 more. So you always just want to basically have them add up to whatever your root is. Yeah, no problem. So I would cube this first so that you don't forget about it. So with that cube, so this cube is the fourth root of 216 x to the 12th y to the third. And then so you would multiply these two together. And so when you multiply those two together, you get a very large number. So you get 104,976 x to the 24th, y to the 25th. So, and then, This one? Yeah, so this one is from the 6x to the fourth y cubed. So I just cube the 6 to get 216, cube the x to get x to the 12th, same thing for the y. And then you multiply the numerator of the very original one with our new numerator. And then here, we get very lucky in that huge number is a perfect fourth. So it ends up being 18 to the fourth. So I'm just going to extend the page so people can see it as I'm working. I'll just go back up when I'm done with the whole problem. So it's 18 to the fourth. So 18 comes out, and then we can deal with the exponents. So So x to the 24th is divisible by 4, so x to the 6 comes out. And then y, we can break up the 25 into y to the 24th times y. Then same as x, y to the 6 comes out, and then we're just left with 1y inside because everything else came out. So then we have that, and then we still have our denominator. So scroll back up. So then we can simplify it. So 18 divided by 6, we get 3. And then the x to the 6, that's x to the 4th, divided by x to the 4th, you can subtract 4 from each. Then we get x to the 2nd. And same thing with y. So we have an implied 1 here. Get rid of the 1, get rid of the 1. With y to the 5th. So our denominator is gone. We still have our radical hanging out. So I'll scroll back up so you guys can see the whole thing. And then this is your final simplified answer. So it's a big one, but the steps are still exactly the same. Yeah. Yep, sorry. Sorry, I always forget to put those back on.